we receive our koa wood, because primarily we're building from koa, we're receiving them in literally a beam of koa wood. It's a big chunk of koa, long pieces that we ideally want them to come this way. And the reason why is we want the wood to actually dry slowly. We actually cut them a very specific way to allow them to dry slow. There's a quarter san, which is vertical grain, which is a specific way how the wood is cut from a log. We're getting the first slice off of the block and the second slice off of the block, and they become a married pair. And what that does, it opens up and reveals this symmetrical grain, or what is known as book-matched grain. We're doing that for the front of the ukulele, the back of the ukulele, and even the sides of the ukulele. And what that does on the final ukulele is it gives the effect that the ukulele was literally carved out of one piece of wood. And it's all through the book matching process and keeping things in order. For the neck on the ukulele, we did convert to CNC technology. It's been a little over a year now, and as long as the machine is well maintained and the programming is done properly, we can get better results. We do have a CNC laser which cuts out the wood. It not only cuts out the wood, it gives us reference points so we can align our braces properly to the lower bout, the waist, and the upper bout. So, you know, on the ukulele, this is the lower bout, this is the waist, and this is the upper bout. We're able to actually get those braces mathematically placed exactly where we need them to be to provide the best support. So you'll see the slot that sits our fret, and the placement in the absolute center of that slot is mathematically placed. It's very accurately placed up on the fingerboard. There's a reason why we put holes. There's also a whole bracing system that's going on inside the ukulele, more than just these transverse or these cross braces. There's lateral tonal bars that are in there too, whereas the traditional brace, this was a solid piece, and there was a series of braces here that looked like a fan, and that just allowed this area to vibrate. With this, we're allowing the whole soundboard to vibrate. We're actually opening up the soundboard by having this tonal bar run the length of the soundboard. But you'll also notice as I pass around the workpiece that each tonal bar touches, releases, touches, touch, release, touch. So each of the pieces have a 20,000th of an inch relief. Why do you do a reverse kerf lining? And there are several reasons. One, the kerf lining gives a wider gluing surface. So when we go to glue the front and the back onto the ukulele, it allows us to have more surface area. So we get better adhesion between the front and the back as we're gluing that to the sides. But by putting this reverse kerf in place, it actually adds a sense of rigidity to the sides too, which is what we're looking for. We're looking for rigidity in the sides as they go through the building or the assembly process. So the wood is constantly moving. When it goes into a drier climate, it contracts a little. When it goes into a humid environment, it expands a little bit. That's the natural progression of wood. It's going to do that. So this finish kind of breathes with the wood is the best way to explain it. It moves with the wood. It doesn't have a tendency to crack over the life of the instrument. It also gives superior clarity. So the color of the wood that you see here, that's the color of the wood. It doesn't give an amber or yellow color. It actually makes the color pop or even become brighter because it has clarity. And that's ways that finishers measure the quality of their finish, the reflection, the depth, of course that wet look, which we're able to achieve. The satin finish is more a hand-rubbed oil process. So more like a French polish approach to oil and wax. So, you know, the small wax circles, kind of wax on, wax off. We're using small swirls with the oil wad for the oiling process, and then putting on a wax. We're still buffing that instrument, believe it or not, after the wax is dried. The satin finish was designed to be really thin, allow for resonance, yet of course still protect the ukulele. And the new bridge was designed for several reasons. One, it gives the technician the opportunity to do a pickup installation in-house, but it then also gave us an opportunity to work closely with Graph Tech to develop a specific Kanilea made saddle. And the reason why we converted to the bridge pin method was it gave us the opportunity to really have the string and the tension that's put on the bridge not solely on the bridge. You know, the traditional tie block, the string tension is on the bridge. That's inevitable. By putting a bridge pin method, we're actually taking the string tension off of the saddle, through the bridge, through the soundboard, and then, of course, attached to the soundboard and the pin holding that string in place. So it helped with relieving the string tension. The saddle, instead of sitting straight up, the saddle actually sits back 10 degrees. And there's a reason why. How the string energy is transferred from the top of the saddle through the bridge and kind of countering the force that it's pulling on, because it's wanting to pull this way, you know, on this plane. But instead of it just pulling on that plane and being straight up, by doing it like this, we're giving a potentially better transfer of energy through the saddle to the bridge to the soundboard by doing that back slope.